Alrighty, everyone. Today we're here to take a look at exponentials and logs as inverses of each other. Ultimately, what I'm going to ask of you is to find the inverse of one function, and then talk about his domain and range and whatnot and all that good stuff. All right, let's take a look at where we're at. If I have, suppose I have an exponential equation like f of x equals, say, 3 to the x plus 1 power, and then minus 2. All right, let's take a look at what we know about this guy. This is exponential, so if I ask you for his domain, I know a domain of an exponential is negative infinity to positive infinity because I don't see any red flags. I know that his range isn't negative infinity to positive infinity. In fact, I know that it'll be from asymptote to infinity, which would be from negative 2 to infinity. And I know that he has a horizontal asymptote of y equals negative 2. So that's an exponential and all the interesting characteristics of him. Now, how would I find the inverse of this? Well, in previous chapters, we said to find an inverse, the first thing you do is you start by, okay, so yeah, we're talking about finding the inverse. Remember that the very first thing we do is we switch the letter x with the letter y in your equation. So if I had to do that in this problem, I would get x equals 3 to the y plus 1 minus 2. Now again, after I do that, after I switch the letter x and y, don't I have to get this variable y alone? Well, again, we know that to get an exponent or a variable out of the exponent, I need to change forms. Since I'm in exponential, I need to change this to log form. But the first thing I'd have to do is to isolate this exponential expression right here. So I add 2 to both sides. I get x plus 2 equals 3 to the y plus 1 power. Now that I've isolated the exponential, I'm ready to rewrite this in log form. Wouldn't this say log base 3 of the quantity x plus 2 equals y plus 1? And then all I have to do is subtract the y alone, the 1 across to get y alone. I get y equals log base 3 of x plus 2 and then minus 1. And that's the inverse of the original equation. Okay? Now, if you look at this, this inverse is a log equation. We know that for a log equation, their domain is not all real numbers. In fact, their domain starts at your vertical asymptote, or h, and goes to infinity. But the range, however, does go from negative infinity to positive infinity. And they don't have a horizontal asymptote, they have a vertical asymptote, and their vertical asymptote is always x equals whatever h's value is. X equals negative 2. Wait a minute. How do these numbers that I just got over here compare to these numbers over here? Well, wait a minute. Isn't the domain and the range of the original just switching places with the domain and the range of my inverse, as we promised they would happen? And look at the horizontal asymptote and the vertical asymptote. To find the inverses, don't you just switch the letter x with the letter y? Well, lo and behold, that's what's happened here. So the reality is, if I want to find the inverse and its domain and range, I do have to do the math to find the inverse, but the domain and the range of one function will just switch places with each other for the inverse. And the asymptote will just switch the x with the letter y. So let's do one more time. If I've got f of x equals, suppose I've got log base 3 of x plus 1 minus 2, and I want to find his inverse. Well, let's take a look at this. I know that I need to switch the letter x and y. So I get x equals log base 3 of y plus 1 minus 2. I now have to isolate the y, or get the y alone. So I need to go into exponential form. Well, the first thing I need to do is I need to get the log expression alone so that I can rewrite it in exponential form. So I'm going to add the 2 across. I get x plus 2 equals log base 3 of y plus 1. I now rewrite this in exponential form. This would say 3 to the x plus 2 power equals y plus 1. Subtracting the 1 across, I get the inverse of x, or the y, equals 3 to the x plus 2 power and then minus 1. Now, the domain and the range, let's go with this. The domain and the range of the inverse. The domain and the range of the inverse, well, the inverse is an exponential equation, so his domain should be all real numbers. His range is from his asymptote, k, to infinity, and he has a horizontal asymptote of y equals negative 1. Now, without even looking, I can take these numbers and plug them up here and just to reverse order. I know that the domain of the original equation should be negative 1 to infinity, because that was the range of my old equation, of my inverse. The range should be from negative infinity to positive infinity, since that was the domain of my inverse. And the original equation will have a vertical asymptote, since my inverse had a horizontal asymptote, and it'll be x equals negative 1. If you think about it, since this is a log equation, agreed, the domain should be negative 1 to infinity, because those are the numbers I'm allowed to plug in for x. The range of a log is always negative infinity to positive infinity, and the vertical asymptote is always x equals h, and h is negative 1 here. Okay? And that's how we find inverses and all their good parts. That's everything. Talk to you later.